We're in section 3.3. Let's do another example where we find all of the zeros of a polynomial function. Just like the last example, this time we're not given any of the zeros in the problem, and so we have to find all of them. We're going to follow the same steps that we did in the last problem. I've written the steps out for us to help us keep track of things. So the first thing to do is to identify all of the possible rational zeros, and then in the next step we'll check as many as we need to in order to factor the polynomial. And so we need to get down to linear or quadratic factors. Those are the ones that we can solve directly without synthetic division. In theory, this could be tedious if you have lots of possible rational zeros, or if you can't find one that works. And so hopefully this example and hopefully the homework problems won't have you doing pages and pages of synthetic division. If you need to speed up the process, remember the zeros are just x-intercepts. So you could look at a graph of f of x, either on a graphing calculator or at a website like Desmos.com. So we're going to check the possible rational zeros. We're going to get down to linear or quadratic factors, and then we're going to finish factoring down to linear factors. If we can't do that, we'll use the quadratic formula on the quadratic factor. Okay, well, let's get started. Let's just restate the problem, right? If we're going to find zeros, then that means we're going to set y equal to 0 and solve for x. So instead of writing y equal to 0, I'm going to write f of x equal to 0. And of course that means the same thing we know from function notation. So f of x is the function 2x to the fourth minus x cubed plus 7x squared minus 4x minus 4. And this is quite an impressive equation. We never had a chance to solve something like this until we got here into chapter 3. And now we have some tools to get through this problem. So let's go ahead and start by writing out the possible rational zeros. So let's see here. So the possible rational zeros would be factors of the constant, which is -4 in the numerator, and factors of the leading coefficient in the denominator. The leading coefficient is this 2 up here. And so how can we multiply to 4? We can either do 1 and 4, or we can do 2 times itself. So 1, 2, and 4 are the factors in the numerator. Factors of 2 would just be 1 and 2. And then we can just take all these combinations. So let's put 1 over 1, and then 2 over 1, and then 4 over 1. And then let's do 1 over 2. And then 2 over 2 is just 1. And so it's already in our list. We don't need to write it again. And then 4 over 2 is 2. It's also in our list already. We don't need to write it again. So the possible rational zeros are just these 8. And so we just want to start checking them. Let's see here. Let's start checking. Let's check x equals 1. And so we're going to put the 1 out front, and we're going to put 2, -1, 7, -4, -4 underneath. And then we've got 2, 2, 1, 1, 8, 8, 4, 4. Hey, this worked out great. We found a 0 right off the bat, so that saved us a lot of time. So we can go ahead and factor our polynomial. So we're going to have x minus 1 multiplied by, and then the quotient starts with coefficient 2, and the power on the variable is going to be 3, since the power on the polynomial before was 4. So we'll have 2x cubed plus 1x squared plus 8x plus 4 is equal to 0. And again, you could always multiply these out and verify that it really does equal the polynomial up above. Okay, so this looks real good. Now, the only issue is, well, we have this linear factor. That looks great, but we've got a cubic factor over here. And so how are we going to factor it? We're going to do some more synthetic division. And so really, we'd like to start again on the possible rational zeros. It's possible that the new polynomial here, that the cubic would have fewer possible rational zeros than the original function. Now, in this case, it happens to be exactly the same, right? It happens to be factors of 4 over factors of 2. And so we have our list already ready here on the right-hand side of the screen. And so we just need to start checking again. And, you know, it's possible that 1 could work again. So what we really need to do is start with 1 again. So let's check x equal 1, and remember, this time we're just dividing into the cubic, so our coefficients are going to be 2, 1, 8, and 4, and when we do the division we get 2, 2, 3, 3, 11. We can see this is not going to work, and so we'll try again. Let's check x equal -1. If we put a -1 out front, and then 2, 1, 8, and 4 underneath, 2, -2, -1, 1. This one's not going to work either, is it? This is a -5. So here's where it could get a little tedious. If I didn't already know the answer, if I hadn't already worked out the problem, then I would probably go on to the 2 and the -2, and then the 4 and the -4, and none of them would work. I would try the +1/2, and it wouldn't work either. I happen to know that -1/2 is going to work because I've already worked it out. So instead of showing you a lot of synthetic division that doesn't work, let me go ahead and show you the synthetic division that does work. So let's check x equal -1/2. And we'll put a -1/2 up front, and then 2, 1, 8, and 4. And then we'll have 2, 2 times negative a half is negative 1, 0, 0, 8. 8 times negative a half is negative 4, and sure enough, the remainder is 0. Okay, fantastic. So what does this tell us? This tells us that negative 1/2 is a factor. I'm sorry, negative 1/2 is a 0. The factor would be x plus 1/2. The other thing that it tells us is how to factor this cubic up here. So let's go ahead and bring it down and write it out. We still have an x minus 1 at the beginning. And then we have x plus 1/2 next. And then we have a quadratic left over since we were factoring a cubic. So this 2 is a coefficient on x squared plus 0x, I won't write that, plus 8 is equal to 0. Okay, and now this looks real good. These are equations, these are factors that we can solve. 2 linear factors to start, and then a quadratic, we can solve that. So let's take each of the factors and set it equal to 0. Let's do x minus 1 equals 0 and get the solution x equals 1. Let's do x plus a half equals 0 and get x equals negative 1/2. You would be correct to point out that this is a little bit redundant. We already know that these are solutions because we already saw the synthetic division work for these numbers. So the last one, the last factor is 2x squared plus 8. This does not factor, but it's not too difficult to solve. If we subtract 8 from both sides and then we divide by 2, we get x squared equals negative 4. And so x equals plus or minus the square root of negative 4. And the square root of negative 4 is 2y. And so there are the last two solutions. And it might be nice if we wrote the answer one more time, if we got all of the zeros together in one list. This is what it would look like. What a nice problem.